All right, greetings everyone. Welcome to the first video for section 4.1, moving into our final chapter of the quarter, which is kind of crazy. Can you believe that we're there already? Time sure does fly when you're having fun. All right, moving right into it. So the beginning of chapter 4 is about what are called exponential functions. So an exponential growth or decay function is a function that grows or shrinks at a constant percent growth rate. And I'm going to highlight this constant percent part. So in chapter 2, we studied what are called linear functions. And linear functions are functions that increase or decrease by a constant amount. So in a linear function, we could be, seeing an increase in someone's earnings of, like $10 per hour. So they're earning the same amount of money per hour, or their wages increase by the same amount of money per hour. Or we could see one where it was like an example we did was something about the population of whales decreasing by like 3 whales per year. So again, there the number of whales decreased by an amount of whales. When we're looking at an exponential function, depending on whether it's growth or decay, and decay means that it's decreasing, okay, we need to have it increasing or decreasing at a constant percent. So we're talking about percents here. Now, the general form for an exponential function, we have two general forms. The first one is this one here on the left, f of x equals a times 1 plus r to the x. Or another common one we use is f of x equals a times b to the x. Okay, and if you write these two formulas right above and below each other, you'll hopefully notice that they're pretty much the same. Okay, so notice that they both have the a value out front. They both have the x in the exponent, and what's different is the 1 plus r and the b. But you can notice that that 1 plus r and that b are basically in the same place. So from what we have here, we know that b equals 1 plus r. Okay, so here's what those things mean. So number one, a, that's the starting value or initial value of the function. Remember, the starting value is usually when the input equals 0. R, the value for R, is the percent growth or decay rate. Now be careful, notice that it does not say B is that value, right? It's the value for R. So notice that B and R are different. Okay, B equals 1 plus R. Also notice here it says that that percent needs to be written as a decimal. And then the last part is B. The value B is what we call the growth factor or growth multiplier. And the most important thing I want you to know about that is B can only be positive values. Okay, so no negative values allowed for B. Okay, so let's look at an example of this. So the cost of in-state tuition for a full year, 3 quarters, at Pierce is currently $4,531.50. If tuition has been rising by approximately 2.7% each year, what should students expect to pay for a full year at Pierce in 10 years? Now, on the previous slide, we had two possible formulas for an exponential, even though they're kind of the same. Okay, so the f of x equals a times 1 plus r to the x, and f of x equals a times b to the x. Now we said that exponential functions deal with functions that are increasing or decreasing in a constant percentage. So since we see there's a percent increase here, then we know we're working with an exponential. But the next question would be, which of these two functions here would be the best one to work with? And I'll tell you right now that the first one is the best one to use when we're talking about percentages. So if you're given a value that's you're told that something's increasing or decreasing by a certain amount, I would use that a times 1 plus r to the x. The second one here, this a times b to the x, is going to be most useful when you're given points that an exponential function passes through. Okay, so in this case, in this problem, we were not given points, so we're going to use the first one up here. So we'll use the f of x equals a times 1 plus r to the x. And so what we got to do is fill in the information we're given here. Forgot that. Okay, so let's see. The value for A, remember that is the starting value or initial value. So in what we're talking about here, the value of tuition starts at $4,531.50. The value for R is the percentage. So we're told it's increasing by 2.7%. So this is going to be, this will be 1 plus R. But now recall that on the previous slide, it said that value for R has to be written as a decimal. So we convert 2.7% to a decimal. And we do that by taking the decimal point here, moving 2 spots to the left. So we see that it's 0.027. And then we're also asked that what the value will be in 10 years. So now we got to think about our inputs and outputs. So what would x be and what would f of x be? Well, there's a couple ways to figure this out. First of all, since we chose our starting value to be the tuition prices, and usually starting value relates to the outputs, it seems that maybe the tuition prices would be our output and the years would be our input. Also, if we think about it, what makes the most sense? Does it make the most sense to input years into a function and output the tuition? Or does it make sense to input tuition and output years? And I would argue that it makes the most sense to input years and output tuition. So that tells us that the value for 10 should go in for x. So we're trying to find f of 10 here. And to save accuracy and headaches from arguing with WAMAP, I would say take this whole thing here, the $4,531.50 times 1.027 to the 10th, put that whole thing in your calculator all at once, and you can actually put it pretty much in as is. And when we do that, we end up with $5,914.89. Okay, so that's the projected cost of tuition for 3/4 within 10 years, or in 10 years. Okay. All right, let's look at another example of interpreting equations. So here we're told that the exponential function below describes the value of a car t years after it was purchased. We have to use our knowledge of exponential functions to interpret the meaning of this function, i.e. interpret the meaning of a and b. So we have this v of t equals 10,000 times 0.81 to the t. Now as it says, we can compare this to the function f of x equals a times b to the x. And as you can see, we can make connections between parts of the equations, right? So it looks like our f of x, or our v of t, excuse me, is our output, which in this case is going to give us the value of the car after t years. The 10,000, write that off to the side, that's the value for a. And so what is that going to represent? Well, since it's representing, or the numbers here representing the value of a car, we could guess that this 10,000 is probably $10,000. And that would also tell us, since we know A is usually the starting initial value, that 10,000 would be the starting value of the car. Okay, so when the person purchased it, that would be the starting value. All right, now the value for B, and this is where we got to be really careful. So notice we say that B equals 0.81, which we know it's in the place of like also the 1.R stuff, so we might also think of this as 81% if we convert it. Which then folks often will look at this and say, oh, the price of the car is decreasing by 81% every year. However, that is not what is happening. Because remember, in our other form for an exponential, so the f of x equals a times 1 plus r to the x, 1 plus R, sorry, R is how much is our rate at which we're increasing or decreasing. And also recall that the value for B equals 1 plus R. So in order to find our percentage change here, what we need to do is take the value for B, which is 0.81. We're going to set it equal to what B is equal to, which is 1 plus R. So 1 plus R equals 0.81. Can solve for R here by subtracting 1 from both sides. And when we do that, we end up with R equals negative 0.19, which if we convert that into a percent now, it's negative 19%. So what is that telling us? So what that's telling us is that the value of the car is going down by 19% every year. So even though the B value was 0.81, the percentage decrease, which was actually negative 19%, or negative 0.19. So again, a decrease of 19% every year. All right, that's all for now. Thank you for watching.